All right, hello everybody. We are back with another transformations video. This one is on something called piecewise functions. And this is an example of one here. Okay, so you see it's not like a normal graph of a shape of one of our parent functions, but rather it's kind of this, it's a pieced together function of all these different line segments that are kind of connected. Okay, and so this is just another example of a function. And what we're going to do with this is do what it asks here. So it says the graph of f of x is shown on the left, sketch the transformations of the function, and it lists these four. So the transformations, all the same rules and all the same like letters in their positions, all those same transformation rules still apply to piecewise functions, even though it's a different shape. And so what we're going to do is look at A, B, C, and D here, and one at a time, we're going to graph these transformations of this function. And so what might be helpful to do too is you're going to have like an original piecewise function. So those 4 points I want to copy here, right? Because I'm going to do letter A. I'm going to do this transformation f of x minus 3, okay? And just notice, we see this function notation here. Again, just think of it as a name, okay? A name for the original function, okay? And so when we see that, that's kind of almost like the original equation. And then we look at, okay, how, based on what's different between just f of x, what's different between that and then what's kind of added to that in the equation, just like when we looked at transformations, that's how we determine how it's going to move around the graph, okay? So I'm going to copy this over here real quick. And so we think, again, same rules of our h and k values and our a value out in front. We look at where that is, we think, okay, what is that going to mean for shifting the shape around? And this minus 3, right, is outside of a group with the x, so that would be like a k value. This minus 3 means I'm moving the whole shape down 3 spots, okay? Right, if this is moving down 3, just count down that many points from each original point. So I have this, shift down 1, 2, 3, there it is. Okay, take the second point, shift down 1, 2, 3. Okay, f of x minus 3 would look like that. Okay, just the whole shape shifted down 3 spots. Pretty easy, right? Let's look at letter B here. Let me erase this. Okay, looking at letter B says f of x plus 4. Okay, and that x plus 4, that plus 4 is in a group with the x. So what does that mean? Right, looking at our transformation equation here, we have this minus h inside the parentheses, right? So this would be like an h value. And again, what does that tell us? Well, plus tells me that I am moving left. Okay, so this is telling me I just count over left 4 spots. Okay, so 2, 3, 4. It's a little bit off my graph, but it'd be like there. Shift left 4, I'm here. Left 4. So this light blue one would be f of x plus 4. Okay, so looking at letter C first, letter C, negative f of x. So remember that negative outside of the parentheses means that is a vertical flip, right? That means we are shifting the shape, right? If it was a parent function, we'd be almost flipping it upside down or turning it. And this is the same thing, okay? Another way to say this is it reflects across the x-axis. So we're taking this shape and we're going to kind of move it across the x-axis. And so if you remember for parent functions, I kind of said, okay, there's your x-axis. So each point is going to kind of move across the x-axis that many spots. But we're going to negate the y value. We're going to make it opposite. So if it's negative 1, flipping it would make the y value positive 1 or move it up here. Okay, so we're moving that many spaces across the x-axis. So this y value is positive 7. Okay, flipping that down would take it to negative 7 down here. Again, the x value stays the same, but the y value shifts. Okay, this is a positive 5 y value, so I make it a negative 5 y value, flipping it across. And this y value is 0, so actually my last point here, you can't really flip that because it's right on the x-axis, so it's going to stay there. Okay, and so this would look like so when I do a vertical flip. So that would be the graph of negative f of x. Cool. And then last one here, again, this is new, so stay with me. Okay, letter D, f of negative x. Okay, now this is going to be interesting. Notice it's a negative, so it's going to be really similar to this, right? Letter C was a vertical flip because that was outside of the x. Now this one's inside, right? And just like how a plus 4 means I shift it horizontally, right? That's what that plus 4 in a group with the x did. And this, it's going to be similar with a negative in the group with the x, okay? Anything that's in a group with the x kind of means a horizontal change, okay? A horizontal flip, okay? A horizontal flip. What does that mean, right? Well, a vertical flip means I take it and I reflect it across the x-axis, right? I kind of turn it upside down. Whereas a horizontal flip means I take it and I reflect it across the y-axis, okay? And so just the opposite, that y-axis is kind of serving as my kind of mirror almost. And I'm taking each point and I'm just going to flip it horizontally, okay? So look, this point right here, the x value is -7. So negating that x value would make it +7, okay? So that would be right here. The y value is 7. That's going to stay the same, but the x value is -5. So negating -5 would make it +5. So I would take that point right here. I'm flipping it across the y-axis. This point here, the x value is 1. To negate it, I make it -1 right here. And then this point is at 6. The x value is 6. So I move to -6. You see it's kind of like an exact mirror image across the y-axis, okay? And so that would be the graph of f of -x. So there's number one. I'm just going to do one more example with you with piecewise functions, and then that'll be it. Okay, so let me erase, and we'll do another one. The same directions, but so it wants us to sketch them and give the domain and range this time of each piecewise function transformation. Okay, so here's my original. Again, if you'd want to, you could copy down what the coordinates of the points are to get it exactly right. So let me sketch that on the new grid here, okay, just to refer to. There we go. Very nice. Okay, and so now I'm going to graph these suckers. Letter A, okay, letter A, f of -x, what we just went over. Okay, so the transformation there is a horizontal flip. And so I'm taking that, I'm going to reflect it across the y-axis. So each point is going to move kind of to the other side of the y-axis, kind of that corresponding negating the x value, okay? So this x value of this point is -7. So I'm going to go keep the y value the same, but move to +7. The next one, the x value here is -2. So I go to +2, keeping the y value the same. And the x value is 0, okay? So the x value being 0, I kind of have to just keep it there, okay? Because I can't negate that. And then this x value is +8, so I come over to -8, comma -4, and I make my point there. So you see that it is a mirror image kind of flipped horizontally, okay? And so now, asked me for the domain and range this time, okay? Domain and range. So what's that going to mean? Again, we asked the question, does it go on forever to left and right for the domain? And then does it go on forever up and down for the range? And those answers are always going to be no, right? You know that because there's not arrows on the ends of these, okay? So instead of lines that go on forever, it's a very small area where these lines hit, okay? But what's the span of x values and y values that this line or group of line segments hits, okay? Because it's still a line, so we still have to account for the fact that all the little decimals in here are going to be touched eventually by these lines, but it's only a short span of numbers. And it can help you to get rid of the black one, the original one. Or as you do it, maybe you want to draw it lightly, okay? Okay, fixed my mistake, it's at -8 now, okay? So the domain, right, that would be the lowest x value that it ever touches, -8. Okay, so I'm going to include that, -8, okay? And then what's the highest x value? So we see it touches all these x values, up until here. And then it doesn't go any further along the x-axis than this. Okay, so what's the highest x value it hits? And that would be 7. Okay, 7 is the highest x value. So we've seen this before, but we kind of give a span of numbers. So we say -8 is less than or equal to x, which is less than or equal to 7. So this is kind of my way of combining the two statements. X is greater than -8, and less than -7, or less than 7. Okay, so it's from -8 to 7, goes between that span of numbers, and that's how I would write that. Okay. Now the range, okay, range I'm thinking up and down. So I'm thinking, okay, what's the lowest y value this ever touches? This can be a little trickier, okay? So you refer to the y-axis, okay? And it never goes below this, right? This is the lowest point on the graph, okay? So I'm kind of ignoring left to right now. I'm thinking up and down, okay? So up and down, that y value is -4. So -4 is kind of that lowest y value, okay? And then it goes up and up and up. I'm looking for what's the highest y value it ever touches. And that would be right here, right? It never goes higher than that. And that y value is 9, okay? So I'd say -4 is less than or equal to y, which is less than or equal to 9, okay? All right, letter B, f of x minus 2, okay? A little bit easier of a transformation for this one, right? We have an x and we have a value in the parentheses with an x, so that is going to be a horizontal shift, and it's in -2 in here, so that means I'm moving this shape right 2, okay? And again, the vertical and horizontal shifts are very easy because you just count from each point over or up and down that many spaces. So for this one, I move each point right 2 from where it was originally, right 2. Okay, there we go. So that is that shape shifted right 2 because of that h value in there, okay? Now again, domain and range for this one, same questions. It's not going to go on forever, but what's the lowest x value it touches, and what's the highest x value it touches, okay? So I want to look for that span of numbers. And so for this, that's the furthest to the left that it ever goes, right? And that x value at this point would be -5. Okay, so -5 is the lowest, okay? And then it hits all the x values in the middle here, all of these, and then the highest it ever goes is here, right? It's not going to go past that. So that x value is +10, okay? So I'd say it's always going to be this pattern. -5 is less than or equal to x, which is less than or equal to 10. And then y value, same question, but now down to up. So the lowest it ever touches is this point right here, and that would be -4. It's actually going to be the same as the letter A here. So -4 to +9, right? So -4 is less than or equal to y, which is less than or equal to 9. Okay, I always get the question, are they always less thans in here? Yes, they are. One more, let me do letter C, and then we're done. All right, letter C, it says 1/2 times f of x, okay? So for the first time, I didn't do one like this in the first example, but I have an a value now. You remember what an a value does? An a value is a stretch or a shrink vertically, right? Either I'm going to stretch it out vertically, make it taller, or shrink it vertically, making it a little bit shorter and fatter, okay? So this, and we said when it's less than 1, between 0 and 1, it's going to be that shrink, okay? So this has, we would say, a 1/2 multiplier, and that denotes a vertical shrink, okay? And so again, what do you do for that? So what the challenge is with this is that normally we count from the vertex and we say, okay, it's half the distance from the vertex, right? That's when we look at parent functions, that's what we do. But there's not really a vertex here to use as a reference point. So instead, we're gonna cut in half. It's still going to be cutting in half the y value distance, but it's going to be cutting in half the distance from the x-axis, okay, if that makes sense. So watch. So this point is the y value is 6. So cutting in half that distance between 6 and right 0, the x-axis has y values of 0, so that would put it at 3, okay. That is cutting this distance from the x-axis in half. And so it's going to be the same for each point. I look at its distance, cut it in half. So this point right here isn't very far at all from the x-axis, right? It's just one space away. But still cutting 1 in half would make it a half, right? So this point goes from being at -1 to -1/2. This y value is 9, and so I cut that distance in half from the x-axis, and I would make that at 4.5, because half of 9 is 4.5 or 4.5. And then this y value is -4, which makes its distance 4 away from the x-axis. So I make that -2 or 2 away instead of 4, okay? So notice what that does to the overall shape, okay? It's still a similar shape, but it's just, right, it's shrunken kind of in half, okay? And so notice the x values stay the same. They're still the same kind of distance horizontally from each other, but vertically it's shrunken, okay? So there's a little bit on piecewise functions. I hope that makes sense. We just do a little bit of a shallow dive into piecewise functions here in Algebra 2. So hope that makes sense to you. Thanks for watching. Good job.